We tend to think of rivers as just, well, landmarks, nice scenery, a line on a map. But there's so much more than that. They're these massive, dynamic systems, and they've got some incredible power. But the amazing part, the part that really gets me, is that we can actually understand that power. We can measure it, and we can even get pretty good at predicting its most dramatic moments. So, yeah, let's get into it.
Just take a look at this. This is where the mighty Yukon River spills into the Bering Sea. It's this absolutely sprawling, intricate network of channels and lakes. I mean, it's just a breathtaking display of nature's engineering, right? And it brings up a huge question. How in the world do you even begin to measure, let alone understand, the sheer force of a system like this?
Well, to answer that, we've got to pull back. We have to zoom way out from the delta and look at the river's entire blueprint, its grand design. Because the secret to understanding any river, it turns out, is figuring out where all of its water comes from in the first place.
Okay, so what you're looking at here is the whole shebang, the entire Yukon River drainage area. Every single one of those little white lines, that's a stream or a tributary, and every single one of them eventually feeds into the main channel of the Yukon. This whole region acts like a massive funnel, and it's the fundamental unit we need to study to get a handle on the river.
And of course, it has a name, a drainage basin. It's a really simple but powerful idea. Just think of it like a giant bathtub. Any drop of rain or bit of snowmelt that falls anywhere inside the rim of this tub, it's all going to eventually flow down the same drain. And that drain is the main river.
So let's make this personal for a second. Here are the major drainage basins of North America. That huge red area, all of that drains down into the Gulf of Mexico. The blue, that heads for the Atlantic. Take a moment and try to find where you live. Where does the rain that falls in your own backyard, where does it ultimately end up? It's kind of wild to see how we're all connected by these massive water highways.
Okay, so now we know where the water's coming from. The next big question is, how do we measure how much water is actually moving through that river at any given moment? How do we take its pulse? Measure its breath?
Well, scientists have a name for this. It's called discharge. And it's really just the volume of water passing a certain point over a specific amount of time. You can think of it like turning on your kitchen faucet. Discharge is basically how many gallons are flowing out every second. Now, for a huge river, we're talking about cubic meters per second, which can be an almost unimaginable amount of water.
So once we have all those measurements, we need a way to see them, to visualize what's happening. And for that, we plot the river's discharge over time on a special chart. It's called a hydrograph. It's kind of like an EKG for a river. It shows us its rhythm. Right, so we've got this chart, this river EKG. But what does it actually tell us? What's the story here? A hydrograph shows us, in perfect detail, how a river reacts to a big event, like a storm. The shape of that curve tells a story. For instance, if you looked at the hydrograph for the 1976 Big Thompson flash flood in Colorado, you'd see this incredibly sharp, sudden spike. That's from a ton of rain falling really fast in a steep canyon. But the chart for the Great Mississippi Flood of 1993, that would look totally different. It would show a much broader, longer peak because that flood was caused by months of rain over the entire Midwest. And it's that spike on the hydrograph that we really need to look at next. Because when that discharge gets too high, that's when a flood happens. And that can be set off by all sorts of things. Rapid snowmelt in the spring, that prolonged rain like we saw in '93, or even something catastrophic like a dam failure. But first, we need to understand a river's home. See, it doesn't just live in its main channel, that little 9-meter wide cut right there. That channel sits inside a much wider, flatter area called the floodplain, and that includes the bottomland and those higher benches. This is all land that the river itself has built, layer by layer, over thousands of years. So a flood, quite simply, is what happens when the discharge gets to be too much for that main channel to handle. The water has literally nowhere to go but up and out. It spills over its banks and spreads all across that floodplain, first covering the bottomland, and in the really big floods, reaching all the way up to those higher benches. In a way, it's just a natural process of the river reclaiming its territory. And this brings us to the most powerful part of all of this. I mean, knowing what a flood is and how to measure a river, that's one thing. But can we actually use all that data to predict the future? Well, the answer is yes, we can, and it's all about statistics.
And this is the key. This graph is where it all comes together. It takes years, sometimes decades, of historical discharge data, and it plots the highest flow from each of those years against the statistical probability of it happening again. This is how we turn a river's past behavior into a seriously powerful forecasting tool.
I know it might look a little intimidating at first glance, but it's actually pretty simple to read. Here's how it works. First, you pick a discharge level you're curious about on the vertical axis, say a flood of a certain size. Then you just trace that line over until you hit the black curve. And from that point, you drop straight down to the horizontal axis. And boom, that tells you the annual probability, the percent chance, of a flood of that size happening in any given year.
Okay, this next part is absolutely crucial because we have to understand what these numbers really mean. You've heard the term 100-year flood, right? Well, that doesn't mean it's a flood that happens like clockwork once a century. Not at all. It means there's a 1 in 100 or a 1% chance of a flood that big happening this year, and also next year, and the year after that. It's all about probability, not some fixed schedule. You could, statistically, have 200-year floods in back-to-back years. It's just like flipping a coin and getting heads twice in a row. It's unlikely, but it can totally happen.
And really, that's the big question all of this science leads to. We figured out how to measure a river's awesome power. We can understand its behavior, and we can even calculate the odds of a major flood. The science gives us this incredible foresight. But does that knowledge actually translate into action? Are our communities, is our infrastructure, are our policies truly prepared for the reality of that 1% chance when it finally arrives?